Okay, good day. Today I'm going to teach Mohr Circle, and before I go into Mohr Circle, I'm going to go in. We're going to look into the rules. Okay, rules of a circle. Okay, what are the rules of the circle? So I'm going to construct a. For this course. Okay, you will need the mathematical instrumentation. Okay, you need to purchase one, and it's required in your final exam, so you need to buy it. So let's look at the rules of a circle. So now I'm going to construct a circle. Okay, so some of you might know this, some of you forgot. So let's look at the rules of the circle. Okay, so I'm going to construct a circle. There you go. This is my circle. Okay, so this is a circle, and we are going to draw. You need to try this at home also while watching this video. So we're going to draw a straight line. Okay, we're going to construct a straight line, and this straight line has to go past the center of the circle. Okay, so we just draw a straight line. So over here, okay, so over here, this is the center of our circle. Okay, so this is my point naught, and from here we're going to pick a point, an arbitrary point, any points that you want. So I'm going to pick a point, and the point I'm going to pick is somewhere around here. This is the point that I pick. So when there's a case, when you have picked a point, I want you to start drawing lines, okay, from one end of the circle like what I'm doing now, and stop where you put the point, pick the point, and then I'm going to draw another line from the point I picked to the other end of the circle, which is the diameter that on the line that we've constructed. So what is very interesting or very obvious is you realize that this angle over here is 90 degrees. Okay, this is 90 degrees. Then we are going to pick, from the center of the circle, right, we're going to pick another point coming here, center of the circle. So what we realize that the angle over here, I'm going to call this alpha. The angle over here is also alpha because they share the same radius. Okay, and then we know the angle over here is equal to 12 alpha. And why is that? Is because the angle over here that's just written down, this angle over here is equal to 180 minus 2 alpha, and over here the 2 alpha is because of the angles on a straight line that's equal to 100 degrees. Okay, so this is the rules of the circle, and to start doing Mohr circle you have to remember this rule. Okay, so I will encourage you to, when you are doing this at home, okay, I will encourage you to measure this angle and measure this angle. Okay, and it's always true that is always 2 alpha, mathematically can be shown. Okay, so that is the rules of a circle. Okay, now next we are going to touch on Mohr circle. Okay, before we go into Mohr circle, I need to explain a few terms in terms of stresses. Okay, so let's look at normal stress. I have to explain what is normal stress. Okay, so the first thing we're going to look at is normal stress. So normal stress are stresses acting perpendicular to the surface. Okay, so I'm going to draw an element. I'm going to construct an element. So this is my element. Okay, this is an element. So an element I will associate it with a transformation. So this is my x direction, y direction, and this is my element domain. Later on we will relate what is an element in real world. Okay, and we can have stresses in two direction. So over here, this is stress x. Okay, so this is my stress x, and then on the other one, this will be my stress y. Okay, so this is our stress y. And when we say the stresses acting perpendicular, so you see where the perpendicularity is. So this is perpendicular. Okay, so stress x is spelled x direction, stress y is spelled to the y axis. So for this case, we realize that stress x, when the arrow is pointing away, so stress x is equal to positive, is because it is tensile. It's pulling away, it's tensile. And then likewise stress y is equal to positive also, and likewise I'm going to call this going at tensile. So for this example, I would like to emphasize that stress x is greater than stress y for this example. Okay. So I'm going to go into Mohr circle domain. So there's an element domain, so we are going to construct Mohr circle. Okay, so to construct Mohr circle, the x-axis is normal stress. Okay, so this is our x-axis. So this is our normal stress, and then the vertical axis, this is our shear stress. Okay, this is our shear stress. And on the shear stress, okay, so this is our 0. I want you to have a habit on the shear stress. I want you to put a clockwise rotation. On the negative shear is an anti-clockwise rotation. Okay, so now, as I mentioned earlier, stress x is greater than stress y on the situation that I've shown. So this is where stress x magnitude is. Okay, so this is our stress x. So this is stress x. And then stress y is smaller than stress x. So this is my stress y. Okay. So because the shear stress is equal to 0, I want you to also have a habit. I want you to label over here, this surface over here, to be your surface x, and this surface over here to be your surface y. Okay, so from here we know that point x on Mohr circle will be here, and over here y. Why is it on the 0 shear stress line? Because your shear stress is equal to 0. That's why it's exactly over there. Okay, and then I'm going to introduce you to a new term, and this is your point O. Okay, so point O Okay, point O is the center of the circle. Okay, so you use your protractor, sorry, your compass to draw Mohr circle. Okay, so you draw a Mohr circle with your compass. This is your Mohr circle. Okay, and I'd like to introduce you to a term over here at point O. Okay, at point O, if I'm going to draw a line coming down from point O, okay, cross point O, and then we're going to construct the distance from 0 stress to this over here. This is also correspond to our stress average. Okay, so if you look at how to calculate stress average, your average or your average stress, so your average stress will be equal to stress X plus by stress Y divided by 1 by 2. Okay, so note that stress are vectors, so they have direction. So take note. Okay, later on I'll show you an example. Let's look at another normal stress acting direction. Okay, so let's look at another configuration. Okay, so let's look at another configuration down here. So for this case, we're going to have stress X. Again, stress X is in the same direction, okay, going outwardly this way. So this is our stress X, and then our stress Y, I'm going to reverse the direction. So this is our stress Y. Okay, so that is our stress Y, and the transformation is the same, so I'm going to copy our transformation. Transformation did not change. Okay, so this is transformation, you know what is X. Okay, so for this case, what we realize is the arrow for stress X is pointing away from the surface, so we can say that stress X, okay, we can make the statement that stress X is tensile, is equal to positive, is tensile, is pointing away from the element. Well, stress Y is negative, okay, because pointing towards the element, so this is under compression. Okay, so now if we were to construct Mohr circle again, okay, so we are going to construct a Mohr circle. So this is Mohr circle now. So on Mohr circle, this is your stress in your X direction, and then the vertical axis is going to be your shear stress. Okay, so this is your shear stress, clockwise direction, anti-clockwise direction. So for now they are still arbitrary numbers. So when it's tensile, what we realize that if this is 0 on the normal stress, okay, tensile is on the left hand side, the right hand side, and then on the left hand side, the negative tau is compression. Okay, so on one side is going to be positive, and the other side is going to be what? Negative. So now we know that stress X is going to be positive. Okay, before we go on, keep on forgetting this. It's a good practice to label this as point X, and over here this as point Y. Okay, so from here we know that stress X will be somewhere along this line. okay, and then your stress Y, which is compression, will be somewhere around here. Okay, because the shear stress is 0 like before, so over here point X is here, over here point Y is here. Okay, so we know that the center of a circle, so this will be our center of circle. Okay, so this is our point O, which is our center of circle, not 0. Okay, point O. Then from here we can draw our Mohr circle. Okay, we can construct our Mohr circle now. Okay, so again, likewise, you can also find out that over here, this is our over here now. So for this case, this over here now is our average stress from here to here, and then again from here to here, right? This is our stress average. So what I want to highlight to you are 2 points. Okay, there are 2 points that I want you to know. Is one point, or is at point X. Point X is, I'm going to call point X stress 1 and stress 2. Okay, there's no reason why one should be 1 and you can go either way also. Okay, so at stress 1 and stress 2, okay, the shear stress i.e. the tau is equal to 0. Okay, so this point or these points are also known as principal stress. Okay, so there's most of it, and I'm going to do another example for you guys. Okay, so we're going to do another example. So we're going to look at the element again. So I'm going to copy the element. So what I'm going to do now, everything's still the same. Okay, so this is our element, and then it comes to a point where we have stress that you have no arrow. When you have no arrow over here, what is mean that stress X is equal to what? Is, for this case, stress X is equal to 0. Okay, because there's no arrow. So now you go on to Mohr circle. Okay, now we go to Mohr circle now. So we're going to construct Mohr circle again. So this is one line. I'm going to have it more compression. Okay, so this is over here. So this is your normal stress, shear stress going clockwise, shear stress going anti-clockwise, and we know that stress X is going to be on the 0 line. Okay, so I'm going to overrun it with the 0 line, and then stress Y is negative. Okay, so it's going to be negative. So this is your stress Y line. Okay, so we are aware that this is your point X, over here is your point Y, so this is your point naught, your center of your circle. You can construct Mohr circle with this. Now you just use your compass, just draw a circle around it. Okay, and then with the center of the circle, the center of the circle over here. Right, so from here to here, from this direction over here where I'm drawing now, this will be your stress average, and you realize that the stress average is in compression now. Okay, so this is your stress average. Now there's a term that I want you to know also, is where you draw your vertical line for your stress average. I'm going to introduce you to another line, okay, and it's the top of the circle on the vertical, okay, and this is known as your, as you can see, your maximum. Okay, this is the one as your tau max. Okay, this is just something. Now the next thing is how is this element related to the real world? Okay, so the next, before I stop for the first part, so we're going to ask, how does the element represent in real world? Okay, so you see Mohr Circle, hey, how is this related to the real world? So if now you have a shaft, right, and the shaft is under different type of stress. Okay, so you have stress 1 over here, you have stress or force 1 over here. Okay, not stress, you have force 1 over here, you got force 2 over here. Okay, then you're gonna the square over here means this is a strain gauge. So a strain gauge changes its resistance upon loaded. Okay, so it's just basically a resistor, it's a schematic is resistant, so you can compress it, or a resistor that you can put it under tensile loading. Okay, so the resistance will change. So if I zoom in, so you put the resistors at one end and you put it at the other end. Okay, so what you get a change in resistance. Okay, so the change in resistance, right, will affect the measured voltage, then we will have a relationship with voltage, and also we can have a voltage with stress. Okay, so there's a linear relationship that you will get. You have a linear relationship. So from here, that's where we measure the resistor. We will know whether it's in tensile or in compression. So you have to attach the strain gauge to the structure that you measure, and then that's where you get your what? Element stresses. Okay. So this is part 1. I'm going to stop here and we're going to continue again. Okay. Thank you.